For the production function to exhibit positive and decreasing marginal returns to labor, we need to have that the first order condition with respect to labor n is greater than 0. So what does it mean? So when MPN, the marginal product of labor, n represents the number of workers, the number of labor. So when MPN is positive, it means that we have positive marginal returns. That means that if we add one extra worker to the production facility, production will increase. Why will production increase? Production will increase because of the first order condition being positive. If we have decreasing, positive but decreasing marginal returns to labor, we need to have that the marginal product of labor differentiated with respect to labor is less than 0. So intuitively, we will have that if we add one extra worker, production will increase, output will increase by, say, 5 units. If we have positive but decreasing marginal returns to labor, we know that, okay, if we add one extra worker on top of the one we just added, we will have that output increases. Why? Well, we know that whenever we add one extra labor to the production facility, output will increase, but not any longer by 5 units. It will now only increase by, say, 4 units. That is what it means when we have positive but decreasing marginal returns to labor. So in order to figure out whether we have positive marginal returns to labor, we have to differentiate the production function with respect to n. So dy over dn. We take down the exponent, multiply by n, subtract 1 from the exponent, so we get minus 1/3 times k to the power of 1/3. This is greater than 0. So what is this also equal to? This is the marginal product of labor. If we have decreasing marginal returns, we need to have that when we differentiate the marginal returns to labor with respect to labor, that the whole expression is negative. So we differentiate the marginal product of labor, we take down the exponent, that is 1/3, multiply by the whole expression and subtract 1. So we have minus 1/3 minus 1, that is minus 4/3 times k to the power of 1/3. Number of workers always positive, number of machines always positive, 2/3 positive, and then we have this minus 1/3, this is negative, so the whole expression becomes negative. So the production function exhibit positive but decreasing marginal returns to labor. And then we do the similar thing just for capital. So does this production function exhibit positive marginal returns to capital? Let's figure it out. So we differentiate the production function with respect to k. If we do so, we get the marginal product of capital. So we differentiate with respect to k. We take down the exponent 1/3, multiply by n to the power of 2/3 times k to the power of 1/3 minus 1, that is minus 2/3. 1/3 positive, positive. This expression is positive as well. So the marginal product of capital is positive. That means that if I add one more machine to the production facility or one more unit of capital to the production facility, production will increase, okay? So production will increase. Are these, is the marginal product of capital decreasing? Well, the only way to figure out whether the marginal product of capital is decreasing is to differentiate the marginal product of capital with respect to capital. If we do so, we take down the exponent times 1/3 times n to the power of 2/3 times k to the power of minus 2/3. This expression here is negative. Number of workers is always positive. Number of machines is always positive. This whole expression is negative. So the marginal product of capital is positive. That means that when we add one extra capital unit to the production facility, production goes up. But since the marginal product of capital is decreasing, we know that because we differentiated the marginal product of capital with respect to k. We know that the positive returns from adding one extra machine or unit of capital to the production facility is decreasing, it's diminishing. So if I add one more unit of capital today, I know that output will increase by, say, 5 units. The next unit of capital I add to the production facility will also increase production, but not by as much as the previous unit we added of capital. The production function y exhibits constant returns to scale whenever the following holds. So whenever we increase both input factors by a factor a, also production should increase by a factor a. So if the production function exhibits constant returns to scale, we know that if I increase both input factors, that is labor and capital, by, say, 1%, then let this a be equal to 1%. So now I increase both input factors by a factor a, that is 1%. Then also production, overall production, should increase by 1%. So let's see if this holds for our production function. Our production function says that y is equal to n to the power of 2/3 times k to the power of 1/3. That is our production function f, which depends on the amount of labor and capital that we have in our production facility. So if the production function exhibits constant returns to scale, how do I test it? Well, let's increase both input factors by a factor a. So now I multiply both input factors by a factor a. So n, number of workers, increase by a factor a. And then to the power of 2/3. Number of capital units also increase by a factor a to the power of 1/3. This we can simplify. We have that this is the same as a to the power of 2/3 times n to the power of 2/3. And the rule we're using here is that a times b to the power of n is equal to a to the power of n times b to the power of n. We apply the same rule over here. A to the power of 1/3 times k to the power of 1/3. Then we have a to the power of 2/3 times a to the power of 1/3 times n to the power of 2/3 times k to the power of 1/3. This here we can simplify. This is the same as a to the power of 2/3 plus 1/3, which is just equal to a to the power of 1. So we have that if we increase both input factors by a factor a, then we have a times n to the power of 2/3 times k to the power of 1/3, which is exactly equal to what we have here on the left hand side. So if I increase both input factors by a factor a, say 1%, we will also have that the overall production will increase by a factor a. So in this economy, production is carried out by the use of workers and capital. So N corresponds to the population or the number of workers. The population size and the number of workers employed in the production facility, these are the same. Why? Because we do not assume any unemployment here. So the per capita production function is also equal to the per worker production function. So in order to find the per capita or the per worker production function, we have to take the production function and divide by n. So we have y, that is our production, over n. So we can simplify. We can write n to the power of 2/3 over n times k to the power of 1/3. This here we can simplify using the rule that says x to the power of m over x to the power of n. That is equal to x to the power of m minus n. So if we do so, if we apply this rule, we get n to the power of 2/3 minus 1 times k to the power of 1/3. 2/3 minus 1 is equal to 1/3. So I get n to the power of minus 1/3 times k to the power of 1/3. So the per capita production function is equal to n to the power of minus 1/3 times k to the power of 1/3. This we can also write a bit differently. We can write this a bit more different. So here we have something to the power of minus 1/3. When we have something that is raised to the power of something negative, we can rewrite the expression to 1 over x to the power of a. So the production function would be 1 over n to the power of 1/3 times k to the power of 1/3. Now I have k to the power of 1/3 over n to the power of 1/3. This is the same as k over n to the power of 1/3.